Hi, everybody. Hello, nice to see you all. It's a little bit out of date. I forgot to update it because I'm an AI instructor. Been doing that for a few years, but I'll send you the update. So, meanwhile, let's see. A slight correction. It's going to be about a part of TensorFlow 2, so technically it is, but it's one particular part. And so before jumping in, I'm going to put the slides online onto SlideShare, so you'll be able to see anything that we don't finish tonight, or if you want to go over it again, of course. So first question, how many people have worked with TensorFlow 1? Couple. Who's worked with TensorFlow 2? Well, the way I describe it usually is that TensorFlow 1.x is like driving a stick shift. TensorFlow 2 is like driving an automatic. Once you get, it's almost impossible to go back. In fact, TensorFlow 1 was essentially, what's the word, end of life, was last October when TensorFlow 2 became production ready. So there won't be any new changes, additions into TensorFlow 1.x. except security-related stuff. So the thing about, just real brief, I didn't put it in the slides, but with there's something called Keras. That's the layer in TensorFlow 2 that makes it a lot easier to do TensorFlow stuff. Keras is actually written by someone called François Chollet, who actually now works at Google. So there's sort of three kind of flavors of Keras. There's Keras.io, which is you could sort of Keras Classic. It's going to live on into perpetuity. There's Keras for TensorFlow 1.x and also Keras for TensorFlow 2. The code in the final versions of TensorFlow 1.x, the Keras code, looks the same for the most part, but there are some differences, specifically with the TFkeras data content. So that's what we're going to look at is TF2, TF.Data, Keras sort of stuff. And if the next question I have is, how many people have done functional reactive programming? Yeah, well then this is going to be very, very familiar to you. It's going to be kind of a subset of that. So we'll get into some examples of this. We'll go through some of these things that I've listed here. Where they like filter and map. Has anyone heard of those? Okay, so those are very popular in a number of languages. You can find them in JavaScript, Java, a bunch of different languages. And in the case of TF.Data, there's going to be a set of other operators. They're typically, there's a little bit of terminology. Operators like this are called intermediate operators. In some languages, well, particularly in TensorFlow, they're not called intermediate, they're called lazy operators. So they essentially mean the same kind of thing. Now, there's a notion of something called a terminal operator. And that's the thing that makes things start executing. For example, in Java, it'd be a for each loop. In TF.Data, it's a for loop. In ReactJS, it's going to be subscribe. So this whole functional reactive programming, you will see it, essentially, it's the prefix of capital R, lowercase x. So there's ReactJS, RxAndroid, RxJava, RxSwift, RxHaskell. Many, many different languages have that. So when you've learned it in one, you pretty much learn it in another one. Now the thing is, with all of these Rx flavors, they have about 80 to 100 different operators. Whereas with TF.Data, there's only about 15 to 20. My understanding is that the team specifically chose to use just implement a subset of those operators. They don't want to get it polluted and bloated, just keep it at a core. So that means it's easier to learn if you only have 15 to 20. So, okay, so with that in mind, let's take a look at, I can't see a little bit here. Let me stand over here. So I kind of talked a little bit about this, and The other thing I probably should point out is that TensorFlow 2 has kind of three main parts. One of them is Keras, which I kind of briefly talked about. Another one is TensorFlow distributed, which we're not going to cover tonight. And the third one is this TF data. And I happen to really like this stuff a lot because it's almost like, I don't know, it's just fun to do and it's not really particularly messy, but it's very, very powerful using very simple constructs. And so just to kind of give you an idea, does anybody work with the pipe symbol at the command line? If you've done Unix related, you know that you have a command and then you have the output and then you pipe it to something else. And what does that do? You could list a list of files. And then from there you might find a sub-list, the ones that have .py extension. And then from there you might look at the ones in there that have a particular variable. And that each time you go through, you're probably getting a smaller list generally. And at the end, you might get a list of files, and maybe you'll copy them somewhere. Easy to do. You command substitution. That's one reason I like Unix so much. So filter is essentially kind of like a Boolean operator. And generally, it reduces the set. The thing is, if you do an operation where the input that you get and then the next layer of output is the same, well, that's like an identity operation. It's kind of useless. So generally, you want it to do something, reduce that set. On the other hand, map is, well, some languages call it apply. I think it's called, I forgot in Lisp. I think it's map or apply. Anyway, doesn't matter. So the idea is you have a function, you specify a function, and you have a set of values. And then you apply or map all those points into that function. For example, like you have f of x equals x squared. It's a parabola in the plane. And if you take the integers from 1 to 10, and you pass each of those numbers into that function, what's the result going to be? The squares of the numbers between 1 and 10, so between 1 and 100. So generally what happens is when you're using the map function, it doesn't decrease the size of the output. It can. Generally what happens is you'll get another set that's been transformed from the original. So transforming the data versus filtering it, subset kind of thing. Now, very simple, very straightforward. So what you can do with these operators and others as well is that you can connect them together, and it's called method chaining. So I could take a set of numbers, let's say 1 to 20, and I filter it, and I'll just get the numbers divisible by 4. And then that result, I'm going to take the numbers and square them. So I just do .filter, .map, .filter, as long as I want. And at each stage, I'm doing some kind of operation. Could be filter, could be map. There's other ones which we'll look at in a minute. So, just a quick question. You probably don't know the answer. Just at a guess. Do you think that if you do a filter and then a map versus reversing the two, map and then filter, will the result always be the same? Yeah. Correct. And we'll see an example of that. So what you have to do to find out it's going to give you the result that you want is that you try the different combinations until, a little piece at a time. Generally, you don't want 100 things concatenated together because what happens if there's a bug? Who knows where it's going to be? It's not giving you the result that you need. So do one operation at a time, one intermediate operator, until you finally get to what you want, and then maybe put just a rule of thumb. Logically connected, related, maybe 4 or 5 of them together. It's your choice in how you want to do that. So, does that kind of give you an idea of what these operators can do? And we're going to jump in, and you're going to be surprised at what you can do, how quickly you can do it, starting from 0. So, I've already kind of talked about some of this a little bit, creating this pipeline. Now, I made the comparison that you can do this method chaining, and it's kind of like the Unix pipe symbol. We have a bunch of things. It's not quite, there's a little subtlety involved in this, which is an important one, which I'll get into a little bit later on. So now, to create a data set, it's actually very simple. Typically, I don't know if it's typical or not, commonly you can take a set of numbers, an array, in Python, and you can get a NumPy array if you want. Or it could be an image with the pixel values for the image, like in the MNIST data set, or it could be from somewhere else. The input part is sort of almost separate from the processing part. You think of it that way. There are two different kinds of tasks, and we'll look at some of them as well. So here's a very simple example. NP is for alias for NumPy. We get an array of 5 numbers, and that's how we create our data set. This is a typical way of doing it, DS for data set. That's it. There's our data set. It does absolutely nothing. Now, if we want to actually go through it, we have a for loop down there. Now the for loop, anyone not familiar with for loops? It's a very common construct. Okay, good. So in this particular case, I kind of throw in another thing as well. I said ds.take, that's another operator. What do you think take means? It means, you know, I'll take 5 or 10. It's how many you want to take. And inside I've got that len of x, so the length of x, which would be 5. I'm making it more complicated than what it is. You don't even have to do that at all. All you need to do is for value in ds, colon. As simple as that, or fewer. Now, the interesting thing is, if the thing after the take is a number that's bigger than the number of elements in the data set, what do you think is going to happen? At a guess. What?
It's going to read, just grab more.
That's one possibility. You know, like you have 10 numbers and you say take 20, it could do 10 and then repeat. That's possible. Or it could be an error, or it could stop with no error. It turns out it's the last one. Once it goes through, it gets what it needs. Beyond that, it doesn't do anything. So if you're expecting to get an error message, it ain't going to happen. So sometimes errors are actually good because then you know at least what happened. Whereas here, you don't know if you went past the end or not. That may or may not be important. So you don't need a try, accept, catch, block, none of that stuff. It just works and works the way nice and smooth and seamless. So, has anyone heard of a Lambda expression? In Java land, it's something like an anonymous inner function. When you have a button and you want to handle a click event, you do a little thing, it's an unnamed function. That's kind of like what a Lambda expression is. Now, what happens is, in some of these methods, of these operators, you specify the definition of what's going to happen with the Lambda operator. Now, a Lambda expression. And the way it works, we'll look at a little bit later. These seem like they're out of, are these in order? Oh, yeah, okay. I thought I had an example of it. So here are some of the other operators I was telling you about. We already looked at map and filter. Take, we kind of looked at. What do you think batch does? It will take, yes?
Batch is data, it's an operator for the batch.
Yeah, it's going to, if you say batch 4, then instead of printing everything sequentially, it's going to take 4 at a time in batch mode, sort of. It's not batch mode. It's the number of things that you want grouped together. It's sort of a grouping, kind of. And flat map essentially takes something and it flattens it out, because you could have nested arrays, multiple dimensions, higher dimensions. It's a little bit different from flatten. They're similar but different. And what do you think zip does? I find this a very non-intuitive name for this operator. I don't know why they chose it. You have a list, let's say, of numbers from 1 to 10, and then you have another list of numbers, and you pairwise group them together. Why is that called zip? I have no idea. I think it would be better to call it pair, maybe, or I don't know. Anyway, it is what it is. So we've already kind of talked about this. Filter is a Boolean, essentially a Boolean, contains Boolean logic. Map, technically, when I was saying the way I was describing it, it's actually technically called a projection. So you have something in a certain dimensional space, and by doing a map, you're projecting the data. That doesn't really give you an idea, any insight into what it does, so it's always better to work with concrete examples. And flat map, as explained down below, does that. So batch, repeat, take, again, I think there's kind of intuitive. Here's the example of two different functions to create a data set. I'm okay, actually, I had to move it over there, it just didn't do anything. So a slight difference, two APIs for creating a data set. One is called from tensors, and then the other one is called from tensor slices. I'm not going to get into a lot of detail about that. You can read up on it later on if you want to. Essentially, they're going to do, it's not a big deal for us to worry about the difference. So now, let's take a look at, we already did this. We're going to do, so in this first example, when we do the first iteration, it's going to go through all the numbers in the array, or in the data set. As you can see, numbers 1 through 5. Now, if we look at this one, same first iteration. Now, here's an interesting twist, variation. What you can do is you can specify a function where you want to do the filtering instead of being inline. And if your filter is very simple, like finding the numbers that are even, you can just do it inline. But if you want, you can, this function is actually very simple as well, but what you specify is a Python function. And there you can write all your Python code to do whatever it is that you want. In this example, there's no advantage to it, but you can see that if you had to do a lot more processing, it would be, you could separate the actual code implementation from where you're specifying, you're invoking that function. This is important. It's a very useful technique, and it's something you'll see with generators. So here we have a data set, the set of numbers, and now we invoke the filter method, which then in turn references that Python function, which does what? Anytime a number comes in, what is it? When is it true? It's either true or false. When will it return a true?
Equals 1.
What?
Equals 1.
Correct. Now, if I had x% 2 instead of x, when would it be true? Or sorry, let me skip that a moment because it's a different function, but yes, it's going to just be a 1. So now, this is the second one where it matched just with the 1. First one was the same as the other previous example. Am I going too fast? No? Okay, good. So, as another example, going back to the Lambda expressions, as you can see in red, this is an example of a Lambda expression where x is just a placeholder. It could be any variable name you want. For convenience, we'll call it x. So what this does is, the thing on the left is going to be an input, which we don't know what it is right now. But whatever that input is, clearly it's going to be numeric because it will return what's on the right. And in this example, what's on the right is x plus 1. So what does that Lambda expression do? It increments the set of numbers by 1. Trivial, not, but we can certainly make it a lot more complicated. So what does this one do? Here we have a Lambda expression, x colon x less than 4. And the data set is going to be the numbers from integers from 1 to 5. So what's the result going to be when we iterate through all that?
A new list.
What's that?
In a new list of up to 3.
1, 2, 3, correct. That's all, and I didn't put the output there, but I think it's obvious. Because x less than 4 is only true when x is either 1, 2, or 3 for that particular data set. Now, we have same setup here, and what did we do? I think I did a duplicate here. I can't see very well, unfortunately. Sort of helps. I'm a little bit myopic, so I can't see the screen either. Okay, so now the filter like we did before. Remember I said if we take the x and replace it by x% 2, what's this filter going to return? When will that one be true? For even numbers, again, still pretty simple and straightforward and intuitive. So now, what do you think this does? Not so trivial and obvious, at least I don't think it is. What does TF not equal X% 2 comma 1? Yes, it's exactly the same output. So, you know, there's a simple way to do things, and then there's a not so simple way. Why on earth would anybody use that when there's the simple way? I don't know, make your code look harder than what it is, maybe? No one would do that, right? We'd always use the straightforward stuff, of course. So if we go through and iterate through this, we're going to get the same output. Moving along, now we have 4 numbers, 1 to 4, and we have a lambda expression. What does this do? It's going to double the numbers. So we go through that loop, the for loop, and we have double those numbers. Okay, still very simple and straightforward. Now what about this one? See how we're doing the filter and a map, and then the one below, DS2, is map and filter? Are they going to be the same? What's the difference? Well, if you take the numbers from 1 to 10, and you extract the numbers that are multiples of 4, it's going to be 4 and 8, and squared is 16 and 64. But if you reverse the order and you square the number, well, 2 is not divisible by 4, but 2 squared is. So you're going to get a larger data set, and you can see from the output. Where did I put it? There it is. So that was the first one. We did the filter and then squaring, and then the second one, the opposite order. Okay, now take a look at this mess. I'm not saying you're going to do this specifically, but just to give you an idea. Suppose you wanted to, what is it going to do? Map lambda, it's going to take the values 1, 2, 3, 4, double them, and then we're going to do a add 1, so that's 3, what is that? 3, 5, 7, no, 2, 4, 6, 8, 3, 5, 7, 9, and then we cube it. And what's that going to be? 27, 125, 343, 789, I think. We'll see. Oh, I got it right. Okay. So why would we do it that way when we could do it this way? See the method chaining? It's a lot simpler to see because you just read it from left to right. The data set starts with a map, takes the number, doubles it, then it adds 1, and then it cubes it. It's a lot cleaner and simpler to understand and follow. Now, there's different ways you can do it with all like this. Another way, which I didn't show you, is you could have, well, it amounts to the, yeah, it would amount to the same thing where you, it's just a matter of stylistically what you'll find a lot of times when this kind of stuff, what they'll do, and it might look strange at first, but I'm sort of used to it, so I prefer it, but I didn't do it, is you line it up according to the dot symbol. So you'll have ds.map something, and then right underneath it, the dot will be, so you'll have all of the operators lined up. That's very common. It might look strange at first, but you'd be surprised. It's very, very convenient because your eyes don't have to figure out what's going to come next. And you can see the sequence. So as I said, I didn't do it here, but that's actually kind of the preferred way to do that. There's no limit to the things that you can concatenate like this. But again, remember, debugging. It's not always obvious what's happening. And, well, that's just the way it is when you're programming. So here's an example. We already looked at it, actually. We're doing a little slightly different here. Here we're taking the range instead of saying a NumPy array. It's going to be the numbers from 1 to 8, and we said take 5. So take 5 means first 5 integers. And, of course, that's what we get. Now, in this example, we're doing that same thing that I was telling you about. I kind of half did it the way I was describing it, not completely. And now here, for value in ds take 4, well, it doesn't really change it from just having ds, because there's only 4 outputs. And taking, say, take 4 is kind of redundant. As I mentioned before, if the number you specify is more than the output set, it's only going to take the number that's there. If it's fewer, it's going to take fewer. And regardless of what you specify, you're not going to get an error. You'll get just whatever it is it can accomplish successfully. Here comes a key point. I mentioned that method chaining is like the pipe symbol in Unix systems and so forth. But there's a very important difference. When you're working on the command line and you have executables generating output, so the output of one is the input of the other, it's the whole thing. All of the output from the command goes all the input to the next one. That is okay sometimes, but imagine the following contrived yet possible scenario. Suppose that our set is not the numbers, what do I have here? First four numbers. Let's take the first billion positive integers. And then we'll say, we'll square them. And then, I don't know, multiply by 2. And then we get to the end and we have a DS take 3. What's going to happen? We're only going to have 3 outputs. So it's pointless to calculate 1 billion numbers squared. It's a complete waste. And then doing whatever else we do. So what happens is this, and this is the key point. When this stuff is being evaluated, it takes the first number at the beginning and it goes all the way down to the bottom to see if it passes all, it has to be in all of those things. If it does match successfully all the operations, that is then put into the result set. Then the next number, and then the next. Now I said it would do a take 3, so that we know already that once we've done, the first 3 numbers will be evaluated to whatever it is that they're being concatenated, the method chaining. And then when we get to the 4th number of the original billion numbers, it's going to fail. So there's no need to make all those other calculations. Do you see the advantage of doing things this way? Far, far more efficient. Moreover, when you're working with a data set, 500 gigabytes can fit on your machine. It ain't going to fit in memory. So what's going to happen is there's got to be some kind of paging mechanism. Well, all these operators in TensorFlow, these intermediate operators over, they manage all of that stuff transparently for you. You don't have to worry about that. Has anyone had to ever implement paging in any on a web page? Was that fun? When it worked, yes, but getting to that point, right? Because what do? Paging, like you got a page on a web page, or it could be an image on a mobile device. What do? Well, you get the next batch and you get the previous one, if it's not the first or the last. So you do some prefetching caching. So when they go to the next page, it looks like, oh, great, it's already there. And then you keep doing that, play that game. But you got to have the right size and you got to coordinate things. You're probably doing some kind of cursor type stuff. And you got to handle whether it's a multiple is exactly right at the beginning and the end. It's not rocket science, but it's just tedious. And thank God, that's another reason why I like this stuff. Don't have to worry about any of that nonsense. Let somebody else figure it out. So we just have the fun. Okay, so now output the same as we said before. So now here's the zip operator. As I mentioned before, notice they're almost the same. There are 5 numbers in both. One goes from 0 to 4, the other one goes from 1 to 4. Goes actually 1, 1, 2, 3, 5. So it's going to be a little bit off. I mean, they don't have to be equal. And so when you look at the output, as you can see 0, 1, 1, 1, 2, 2. I had to chop off some of it because they didn't fit on the screen. So this is an example, again, of doing a zip. 2 data sets. I mean, this is one way to do it. Now, let's take a look at this one. Pretty much same. We've got 0 to 10, 1 to 11. Oh, but now look. We've got dx, dy, the 2 data sets. D2 is a zip followed by a batch of 3. So what's going to happen? They're going to get multiple groups of 3 together of that output. I think I gave you the, yeah, it's not too nicely laid out, but that's what it is. Let's take a look at this one. What does this one do? Well, it's another zip and a batch 4, but look at the range. It's going to be the numbers from 1 to 100. What's the second one going to be? It goes in the other direction. Nothing wrong with that. I'm not sure when you would actually do something like that. The positive integers and then the negative on the other side. zip them together, well, just to see what happens. But it's going to work. Semantics are the same. The numbers are irrelevant. Same idea. And then we had a batch of 4. So you can see 0, 1, 2, 3, going along. Notice 0, -1, -2, -3, etc., etc. Starting to get a little messy now. That's TensorFlow for you. So now, generators. This is actually interesting because first time I saw generators was in ECMA 6, JavaScript 6, they called it, I think. Something like that, ES6. When was that, 2013? Anybody do JavaScript web development? So they had this notion of a generator, and what's kind of interesting or confusing is that you define a generator. I call it GENER just for convenience. You can call it anything. And you notice here we have a variable initialized as 0, and we do a while I is less than the length of that, which is 7. And now you see that yield statement, and then I plus equals 1? This does not execute the entire loop. This is the key psychological, technical point, but it psychologically was confusing to me. So what happens is when it encounters a yield, that value is returned and it pauses. It's kind of the semantics of a pipe, if you think about it. A pipe has a reader and a writer, producer, consumer, whatever way you want to call it. So there's that push-oriented and pull-oriented. This, when you're doing Unix, you know, one thing pipe to the other, that's push. It's pushing the output to another thing, and then the next guy responds to it. This doesn't push anything. It's pulled by some other piece of code that says, I want some data. Just an important little distinction there. This is also true of, anyone work with Golang? So you have channels. From what I remember, channels are pull. There's the typical channel has, it pulls a value, it can be populated with one value, and it stops and it waits until a reader pulls that value. There's another one that you can add a lot, you can pile up a bunch more, I forgot what that's called. It's another type of channel, not the default one. So they give you both in essence. So this is quite common, this kind of functionality. Well, it's just, they don't call it a pipe, but it acts kind of like a pipe. So let's take a look at something. Here we have, and again, I did this size 2 times 9 just to obfuscate things a little bit. We don't need that. Whenever we do our for loop, doesn't matter. Take is the thing that you want if you want to take a number of elements that's smaller than the result set. So if you'll notice at the top, do you see how the data set's defined? Is different than the other ones, because now it says from generator. So that means there's a Python function that's going to be like that pipe, the producer. And it's, in this case, called gener, which is this. And it's got tf in 64. This is necessary because, well, this is the way they decided to specify what the return type is. It's going to return an integer. It's going to be tf.int64. It's an integer. So that's why here, you see there's no return there? It just, but that's what the yield does, the return. And this is just, you know, the way that they figured out how to do it. Does it have to be this way? No. But I guess for enough people there, it made sense and they like it. So, you know, you just get used to the semantics. So what's going to happen is we take size is bigger than the length, so it's just going to be all the numbers. And as you can see, we have 0 to 6. Why is that? Because we had range 0, a range 0, 7. That's the number 0 through 6 inclusive. Okay, does that make sense? This is sort of the hardest part, conceptually, if you're going to be using generators. Now, when you're working with TensorFlow 1.x, those of you who have, remember session? That's all gone in TensorFlow 2. Session, global variables, placeholders, all that stuff, thank goodness. What they use instead of a session.ses.run and your variables that are good is you use essentially a generator. And so that is identified by something in, it's called a, the word escapes me, but it's at an at TF function. That means it's going to be a generator. Decorator, thank you. It's the little things start slipping. And so it's good to know this because you can use it with tf.data stuff with operators. You can do it with TensorFlow 2 Keras code. That's going to be the replacement for your tf1.x code. And you can also do it in JavaScript or ECMAScript. What is it at now? ECMA 8 or something? I don't remember. So let's take a look at, now let's take a look at this one. Now look at this. I did a from generator, I'm calling it generator. Look what we have. We got 3 things there. What does that mean? There's going to be 3 things returned, like a batch. Think of it kind of like that. Now, I realize this is contrived, typically not something you're going to do, but in case you ever need to, you notice here, I've got x and I've got len x over 3. So, and then I'm going to have a yield, and look what I have, I plus 1, I plus 2, and then below that I increment by 3. Kind of hokey. I'm taking 3 things and then I'm skipping over, almost like a pointer style. Just to illustrate the fact that that's how you would do something like this. You have your generator, it's going to turn 3 integers at a time, so you're essentially, for value in that, .take, print the values, and this is what you get. Notice over there, 0, 1, 2, 3, 4, 5. Is that right? 3, 4, 5. And I think this one here I was actually in the next one. Does that make sense? So you already know a good portion of operators in tf.data. Now you can also work, as I mentioned, you can work with data sets for the pixel values for images like MNIST. You can also work with text. As an example, I'll just describe the task. We want to take the lines out of this text file where we skip the ones that have a pound symbol. That would be like a comment. So, and then take the first 2 after that. So we want to find and display the first 2 non-comment lines of a text file. Why, I don't know, just for purposes of illustration. So here's the text file. So what, I put it in red. The output that we want is going to be the first red one and the second one. We don't get anything else because all the others are comments. So here's the code. Now we specify an array of file names. This isn't restricted to just one file, but for this example, we're going to do just one. Now, as you can see, the data set from tensor slices goes into file names, which is that one particular file. We just saw what the file looked like. So now what do? What does this do? Not quite so trivial and obvious as the other examples. But if you notice, the flat map defines a Lambda expression. And what it does is, this file name is whatever the file name is passed in, and it's file.txt in this example. And then it'll wrap that file name into this thing called tf.data.TextLine.Dataset, because it's a text line data set. And it skips 1 for whatever reason, just to throw that in. And then, we're doing method chaining. Now it does a filter where it's going to be passing in a line at a time. Each of those lines, what does it do? tf.not equal, this is a little tedious. What do you think that does?
Strips out the comments.
It doesn't strip it out. It does a comparison. It looks at tf string substring line 0, 1. So starting in position 0 for a length of 1, meaning the first character. And it then says, is this character not equal to that pound symbol? If that's true, it's a non-comment line. That's what we want. We're extracting the non-comment lines. And then look what happens there. For value in TS take two, boom. It's going to take, we've got the list of that flat map, produces it extracts a subset of the lines, which is the lines that are non-comment lines. And there happen to be just two of them. There could have been more. But now here, what we do is we just do take two, and what we get is this. So I said that working with operators is fun and simple and straightforward a lot of times, but it can be a little bit non-intuitive when you have to do stuff like this. And you can combine it with tf.text, which is a new module in TensorFlow. It's only in TensorFlow 2. And if you want to do NLP type stuff, you can use tf.text. But you can also combine that with tf.data operators as well, depending on what you're trying to do. So I think I might have an example. I don't remember. Tokenizers and tf.text. There's the command to install TensorFlow-text. That's the tf.text package. And so I listed some, here we have our slices, so to speak. We have documents. We have two. Each one of them is a document. You know, it's only three words long, but treating them as a document. And so now our tokenizer from text, which we've imported, tokenizes on white space, which is typical, at least in English, and many other Indo-European languages. And so now what we have here is our tokenizer, and then our documents, we do a map on the document data set. And there it is. So we can print the result as a list in Python, which displays character strings preceded by the character B. That's just a Python 3 thing. And those other ones are the ones that I was experimenting with before, so you can play around with that if you want. So now we have an example of TF data with MNIST. Does everyone know what MNIST is?
The handwriting digit data set.
Yeah, so it's about 70,000 thumbnails, each of which is 28 by 28. And each thumbnail is the representation as a bitmap of a handwritten digit, 0 through 9. So there's 10 classes. And so, as you can see, if you're not familiar with TensorFlow, or at least working with MNIST, notice how we've gone to something that's a little bit different. Before we were doing tf.data.stuff, when we want to get an actual data set, meaning built-in things, about 8 of them in TensorFlow 2, you have to go through this package, tf.keras.datasets, and then .mnist, and then at that point you can actually just right off the bat load data, invoke that method. And that, on the left, Python's nice about this, it splits it into the part internally that's been, there's a training part and then there's a test part. It's all done in one line of code. It's really nice. And then we take the train part and we split that into 2 parts. That's a vertical split. And so, I won't get into too much detail about all this, but so when we got MNIST_DS, we've got the data set. If you print this, you're gonna have a ton of numbers flying, because you're gonna have about 50,000 images of 28 by 28 integers, 0 to 255. What I did was I did a print. I just did a take 2, but I'm only going to show you a little piece of one of them because it doesn't fit on the screen. But those are the numbers. Those are the actual pixel values for the first digit. And if you run it from the command line, it's a little bit better. So you can, it's almost effortless to get access to all the pixel values of all the images in the MNIST dataset. And you can do it with the Iris dataset and various other ones that exist. So I think we kind of did some of this already. We saw the yield. I think this is actually a duplicate. And what else do we have? A couple of other things that you can do. There's a built-in, like we saw with the, when we extracted the text and the white space tokenizer. There's all these built-in classes. And so it and I didn't go into the detail, but there's something called the TFrecord in TensorFlow 2, and you can create custom records, and they handle all sorts of data. It can be text, it can be or binary data, do all kinds of stuff. So I just kind of stubbed in sort of the flow. It's more pseudocode actually. Notice I didn't fill in all the details, but if you wanted to do something with your custom records and you wanted to process it through a Keras, TF2 Keras model, this would be sort of the code that you would do. The fit, and when you create a model in TensorFlow or most languages, first thing you do is you compile it. And then after you compile it, you train it. But it's not called train, it's called fit. And you can do a train and fit together, or compile and train if you want. But this is the basic standard sort of syntax when you're working with models. And again, I won't go into details because I think most of you haven't really worked with machine learning models. Just to, yeah, well, there's some other sort of, you can do some parallelization if you need to for performance reasons. And then there's some other sort of hints and tips and best practices. I'll skip over these slides. Some of the options that are available, you can do various other things, and even threading if you want, if you really, really have to. And so this is just an example of how you can set some options as well. And so this is the list of data sets that are built in. Notice MNIST is at the bottom. But there's things like Reuters, there's the fashion MNIST. People got tired of the MNIST data set with digits. They came out with this other one. And IMDb is another good one. And so, oh, just some books. I'll skip this one and this one. That's the one I wanted you to see. I have an NLP class starting Friday. Now, later on, there's going to be, when is it? In June. There's a deep reinforcement learning class. Please don't register for it. It would be nice to have you join. Please don't register for it unless you've taken deep learning classes. It's going to be really intense. So essentially, the machine learning requires Python background, and then the deep learning requires the machine learning background, and then this one requires deep learning, and this one requires that one. So,
Can you draw the dependency tree?
well, it'll be listed on the web page if you go there, and it'll have the prerequisites. So, deep reinforcement learning is the last. Before that, you would take NLP. Before that, you would take deep learning. Before that, machine learning. Before that, Python. That's top to bottom. The reason for this is I always have one evening. It's 10 weeks, 3 hours a night, once a week. I always have one evening where I do introduction to reinforcement learning. You know, that's the new hotness this year and last year. NLP is as well. And what I found consistently, after the first evening of doing reinforcement learning, everybody wants to learn it. In the machine learning classes, deep learning, of course, everybody wants to see it. Then I ask how many people are interested in taking like a full time class? 20%. 80% are like, no, that's good. Thank you. Showed us enough. Don't need to learn anymore. So that's why I want to make sure that people take the class where there's a 1 3-hour presentation. Then those other classes have 3 weeks of deep learning, of reinforcement learning. And then, so there's going to be 3 weeks in here, 3 weeks in there. This is the 10-week one. And it's not for the faint-hearted. You have to be exposed to it. And I would say that, I mean, the only other places that offer this course are Stanford and Berkeley, in person. So, and I'm covering essentially the same content. So it's going to be intense, not to scare you off, but just so everybody gets the idea of what's involved. And if you have questions, just ask me. So again, I'll put the slides up on SlideShare, send you the link, probably tonight. And I think that's it. So, any questions? Do you feel like you learned something tonight? I think so. By the way, this is my third hour of my Thursday evening class last week. These are the slides. Yes?
I have a question. Is there any differences between operator type when you're working with the tensor and versus the NumPy array? Can you go into particular, or is there some limitations with using the tf tensor?
Generally, yeah, the thing is that what TensorFlow is doing is moving away from Python in the sense of, see, every time you go between TensorFlow and Python, there's a context switch, and that makes it slower. So they're trying to move everything into TensorFlow itself. Now, I'm not sure, there's TensorFlow 2.1. I don't know what the new added functionality is. It's going to be some increment. Potentially what you've described, if they're going to, one, reduce the context switch, if there is one, and by doing so, probably also eliminate any gotchas that could occur. I haven't encountered them, but I don't spend a lot of time with like really huge data sets working on this. So I don't know exactly the answer. It's possible. But for the most part, you'll be okay. All right, anybody else? Yes, sir.
Deal with, if you're setting up these filters and so on, one right after the other, how do you deal with errors? Is it better to have your tries at the top or inside? Or
Well, the thing is, it won't throw an error. So if you do try catch or try accept, there's no error thrown.
I mean, what if rather than, you showed an example where you're dealing with integers, and what if you pass it a none or a string? What does it do? Nothing.
Sure, it's either, well, what'll happen is typically you'll get an error message or it just will fail. So it's almost like, it reminds me of TDD, test-driven development. You write some code, test it, write some code, so you incrementally enhance your code with the goal of getting toward your final set of whatever methods that you want, method training involved. So not all at once, do it a little bit at a time, lots of documentation, so that the next person who comes after you will be able to have a better understanding, or maybe you 6 months from now and you've forgotten what you did or why you were doing it. So document things, split them up, do the incremental testing.
But there's no control over what data you send to it. I mean,
well, you control that.
It may be written properly, but the data...
Oh, sure. I mean, you're going to do some pre-processing to, making sure that the data is valid. Just like you do in machine learning, you clean the data to make sure you have valid data going in. So, yeah, you don't want to have the errors occur when you're doing the crunching. You want to do the pre-processing part, take care of that. Of course, always want to do that. And yeah, that's basically it. All right, well, I think there's probably a few more pizza slices and drinks left for anybody who wants any. I'm full, so. All right, thanks very much.